The theoretical apparatus that we're going to examine here is applicable to all sorts of choices that people might make, ranging from consumer choices to choices as to working, for example, how long to work and for what wage and so on. But what we're going to use it for is thinking about consumer choice in particular. And even more specific than that, we're going to use it as a way of trying to explain demand for a product. When we talk about the demand for a product, we mean the maximum quantities that a consumer is willing and able to purchase at various prices. That's what we mean by demand. What we're going to be looking at first is the able part of that definition. And then we'll go on to look at the willing part of the definition. Because when we think about how consumers make choices, we're going to suppose that they would want certain quantities of goods, but they might not be able to acquire all of those quantities that they would desire or prefer. So we need to think about the constraints on their choices, what they're able to acquire, and then given what it's possible for them to acquire, we can then think about, well, which options will they then prefer, given those constraints. So let's get going on the constraint part, or what a consumer is able to do. So what we're going to aim for is to theoretically construct and therefore provide a particular theoretical explanation for consumer behavior and certain aspects of consumer behavior. For example, we can try to explain why it is that the law of demand holds. Here is a demand curve, and this shows the relationship between the price of a movie ticket and the quantities of movie tickets demanded. And we can see there that as the price of movie tickets falls, the quantity demanded rises, and vice versa. When the price rises, the quantity demanded falls. This is a law of demand, and our question is, well, why is that the case? Why is it that when the price falls, the quantity demanded rises and vice versa? We also might want to say what happens to the demand curve when other factors affect the consumer. For example, if a consumer's income rises or falls, or if a consumer's tastes change in some way. So that could cause the demand curve to shift to the left or to the right, because we're not talking about the price of a ticket here, we're talking about other factors which could affect the demand for a product. So our goal is to try to understand these basic features of consumer behavior using the theoretical apparatus that we'll look at now. Okay, now we're going to construct a diagrammatic representation of the constraints on a consumer's decision making. And to get that going, we need to make some assumptions. The assumptions are either a little bit unrealistic but not crazy, or they're made for reasons of simplification. So the first assumption we're going to make is that the consumer doesn't have an infinite amount of money at their disposal. That is, they have a limited budget with which they are working. As to why and to what extent their budget is limited and what can affect their budget, we'll leave those questions aside for now. Let's just say they have a limited amount of money to spend. The second assumption we're going to make, also an entirely plausible assumption, is that the prices of the goods that the consumer is choosing between are non-zero. That is, the goods are selling for some price or other. The consumer will have to give up money to obtain certain quantities of them. And the lucky last assumption we'll make, which is clearly just a simplifying assumption, is that we'll say that the consumer is choosing between only two types of goods. They're not choosing between 3 or 10 or 85 different types of goods, just two types of goods. This keeps the analysis nice and simple. So here's how our story goes. Let's say we've got a consumer, Tina, and Tina has $40 a day to spend on two types of goods, soft drinks and movies. Let's assume that the price of the soft drinks are $4 a case, and the price of a movie ticket is $8. It's pretty cheap. Given that information, we can then plot on a graph and put into a table all the possible combinations of movie tickets and soft drinks that Tina could purchase if she spent all of her budget per day. So we can see there, in the first case, if she spent her entire budget on soft drinks, since soft drinks are $4 each, her budget's $40, she could buy a maximum of 10 soft drinks. But if she decided to spend a bit of money to see one movie, then she would have to give up some of the money she'd spent on soft drinks and spend it on the movie. So she would only be able, she could afford to buy one movie, but now she could only afford 8 soft drinks. Or alternatively, she could afford to purchase 2 movies at $8 each. So give it cost $16. And with the remainder of her budget, she could buy 6 soft drinks, and so on to the other extremity on the horizontal axis, where Tina spends all of her $40 on movies. Since the movies are $8 each, that enables her to purchase 5 movies during the month. So there we have all of the combinations of soft drinks and movies that Tina could afford to purchase, that she is able to purchase. And we can call this set of options, when we've drawn it onto this Cartesian plane, y-axis and x-axis, we can call that a budget line. It tells us all the combinations which are affordable. Of course, everything under the budget line is also affordable. And everything beyond the budget line is unaffordable. Everything on the budget line, these are the maximum possibilities available. These are the maximum quantities which Tina is able to purchase. Okay, let's muck around with this budget line a little bit now. In particular, there's an easy way to construct a budget line. Given the data that we've already got, the budget of, Tina has $40 to spend, and we've got the prices of the 2 goods. We can find the intercepts for the budget line by simply putting the budget of the income or the budget of $40 over the price of, for example, soft drinks, and that will tell us the maximum quantity of soft drinks that could be purchased. And then we can think of the other extreme. If you spent the entire $40 on movie tickets, how many could be purchased? You can see that 5 could be purchased because we put the income over the price of the movie tickets. Tells you the maximum number of movie tickets you could buy. And then we can just join the dots. Put a straight line, a ray, through the vertical and the horizontal intercept. And this gives us our budget line. It's an easy way to draw the budget line. And now we can think about, what if we changed the change Tina's budget. That is the amount of money she's got to spend per month. If we made it $20, then we could say, well, the maximum number of soft drinks that Tina could buy would be $20 over $4 per soft drink case, which gives us 5 cases. And $20 over 8 movie tickets gives us roughly 2.5 movie tickets. Well, not roughly, exactly, 2.5 movie tickets. So these are the two extreme points on the budget line. So we can see that the budget line has shifted inwards because the amount of money that Tina has to spend has fallen. She is able to buy less of both soft drinks and movie tickets. What if she had more money to spend? Let's say she had $60 to spend. Well, if she spent the entire $60 on soft drinks, they're $4 each, so she could buy 15 soft drinks. At the other extreme, if she spent the $60 on movies, they're $8 each, she could buy 7.5, it seems odd, 7.5 movie tickets. Theoretically. Okay. So we can draw the budget line shifting outwards, indicating that Tina is able to purchase more soft drinks and movie tickets due to her higher income or larger budget. So, changing the amount of money the consumer has to spend shifts the budget line either inwards, less money to spend, or outwards, more money to spend, parallel to the original budget line that we started with. Now let's look at a scenario where the budget line will shift because of a change in the price of a product. Here we're going to change the price of movies. So when Tina has $40 to spend, she can spend, if she spent all of it on movies, they're $8 each, she would be able to buy 5 movie tickets. So far so good. What if the price of movie tickets fell to $4? In that case, with her $40, if she spent all of it on movie tickets, she would be able to buy 10 movie tickets now. What about soft drinks? Would she be able to buy more or less soft drinks than before? Her budget is unchanged, $40, and the price of soft drinks is unchanged. So that vertical intercept is not going to move anywhere. It's still the case that the maximum number of soft drinks that can be purchased is 10. So we would be pivoting the budget line outwards with the vertical intercept at point A as the fulcrum. What if the price of movie tickets increased? So instead of being able to buy more than before, now Tina can buy less than before. If the price of movie tickets went up to $20 a ticket and she still got only $40 to spend, that means she would only be able to afford to buy 2 movie tickets. So the budget line would pivot inwards, indicating she's able to buy less than before. Okay, so by manipulating the price of one good, we can pivot the budget line for the consumer, either inwards or outwards, towards or away from the origin point. What you'll notice there is that this budget line has changed its slope. And this is an interesting, well, in inverted commas, interesting point, because We can calculate, if we want, the slope just by looking at the numbers here. So the slope is the rise over the run. So if we took the outermost budget line, we can see that the rise is from 0 to 10, and the run is from 0 to 10. So 10 over 10, the slope is 1. And we can see that for the middle budget line, the rise is 10, and the run is 5. So 10 over 5, the slope of the middle budget line is 2. Okay, and so on. So here's the interesting thing. The slope of the budget line also, it corresponds to the price ratio for these two goods. In particular, the price ratio, the price of the good on the horizontal axis over the price of the good on the vertical axis. So the price of X over the price of Y. Or in our example, the price of movie tickets over the price of cases of soft drinks. And we can see that here. So if we look at the innermost budget line, the slope is the price of movie tickets over the price of the soft drinks. The price of movie tickets for the innermost line is $20, and the price of the movie tickets is 4. So the slope is 5. If we move to the next budget line, we can see that it's less steep. And we worked out it was 2, and if we do it this way, we can see again the slope is 2. So the price of the movie tickets over the price of the soft drinks gives us our slope of 2. And lucky last, if we looked at the last budget line, the one that is least steep, you can see that the slope is 2 because we put the price of the movie tickets over the price of the soft drinks, 4 over 4. That's wrong. 4 over 4 should be 1. Let's see if I can fix that. Yeah. 1. Okie doke.